All right, today we're doing something a little different. We're going to pull back the curtain and look at the exact playbook hackers are using right now to exploit AI. And this isn't just some theory, right? This is how the tech that's literally changing our world is being turned into a weapon. So let's dive in.
I mean, just think about that for a second. This isn't a science fiction movie plot. This is a real warning coming from some of the world's top AI hackers. And they're not talking about just making a chatbot say something silly. No, they're talking about a full-on compromise of an entire company, all through its AI. That's the new reality we're facing.
And if you think that's just hype, get this. The quote about one of these attacks being unsolvable, that comes directly from Sam Altman, the CEO of OpenAI. You know, the company behind ChatGPT. When one of the biggest names in the game admits that a core vulnerability in his own tech might be impossible to patch, you know we're in completely new territory. To really get a handle on the situation, a lot of experts are saying we need to look back in time. They describe what's happening right now as a new Wild West, kind of like the early anything-goes days of the internet.
Yeah, this comparison comes from an AI security expert named Jason Haddock. He says it feels just like when web hacking started, and a trick called SQL injection was absolutely everywhere. That was basically just feeding a website a little bit of malicious code instead of, a normal search term. For today's attackers, AI feels just like that. A total gold rush of new, wide-open vulnerabilities just waiting to be exploited.
So what does it actually mean to hack AI? Because the attack surface, the number of places a hacker can get in, it is so much bigger than you probably think. Of course, you've got the obvious target, right? The little customer service chatbot on a website. But it's also the internal apps that companies use, like a sales bot running in Slack. It's the AI-powered APIs that your favorite apps depend on to work. And get this, it's even systems where the AI is totally hidden, making decisions behind the scenes that you never even see. This goes way, way beyond just jailbreaking a model to get it to ignore its safety rules.
In this new Wild West, the hacker's weapon of choice is a technique called prompt injection. You should think of it like a master key, one that can unlock even the most advanced AI systems. And yep, this is the exact attack that OpenAI's CEO is worried might be unsolvable.
So here's the really crucial part. Prompt injection doesn't require you to be some master coder. No, it's an attack that uses plain old natural language, words and sentences, to trick the AI. You're not breaking the system's code, you're actually using its own intelligence, its own logic, against it.
Let me show you how this works with a super simple example. There's this little training game called Gandalf. The whole point is to get the AI to tell you a secret password. Now, at first, it says no. It follows its rules. I can't do that. But with a clever prompt injection, just by rephrasing your question in a tricky way, you can fool it into completely ignoring its own rules and spitting out the password. It's actually really fun, and it's a perfect way to see this whole concept in action.
Okay, so playing a game is one thing, but out in the real world, hackers have turned this into a cold, hard science. So let's open up their professional playbook and see just how dangerous these attacks can get.
That AI hacker, Jason Haddock, he and his team actually created a whole system for classifying these attacks. They break them down into 4 parts. You've got intents, which is just what the attacker wants to do. You've got techniques, which are the methods they use to do it. Evasions, which is how they hide the attack from security systems, and utilities, which are just helpful tools. It's a framework to bring order to all this chaos.
Now, when we dive into the techniques, things start to get pretty wild, starting with one called emoji smuggling. And yes, that is exactly what it sounds like. You can hack an AI with nothing more than a simple emoji.
So how does that even work? Well, a security filter, it just sees a harmless smiley face, but hidden deep inside the raw data that makes up that emoji is a malicious command. So when the AI processes it, it doesn't just see a picture, it actually reads that hidden command. It's an absolutely brilliant way for attackers to sneak past security systems that are only trained to look for suspicious words. Okay, here's another incredibly creative one. Let's say you want an AI image generator to make a picture it's not supposed to, like Donald Duck smoking. The filters will probably block that. But what if you rephrase it? Use a bunch of synonyms and super creative descriptions like a short-tempered aquatic avian in sailor attire engaging with a smoldering paper roll.
Well, a lot of the time, that'll sail right past the content filters. And it gets worse. Attackers can actually turn the AI into a data-stealing spy for them. Using a technique called link smuggling, they can trick an AI that has access to sensitive data, let's say a customer's credit card number, into disguising that number as part of a fake image link, and then send it directly to the attacker's own server. So when you start combining all these different pieces from the hacker's playbook, all the intents, all the techniques, all the evasions, the number of potential attacks is just mind-boggling. Based on this one framework, we are talking about 9.9 trillion possible combinations. That's the sheer scale of the challenge that the defenders are up against.
All right, let's make this less theoretical, because this isn't just a possibility, it's already happening. Here's a real-world case study from a penetration test, a pen test that Jason Haddock's team actually did.
So there was a company that built what they thought was this super helpful sales bot inside of Slack, but it had a total cascade of security problems. First, it was sending sensitive customer data from Salesforce directly to OpenAI, something the company didn't even fully realize was happening. Second, it had zero filters to check what users were typing in or what the AI was sending out. But the real killer flaw was the third one. Its API keys were overscoped. They gave the bot full read and write access. The result was a hacker's dream. A simple prompt injection could tell the bot to not just read sensitive data, but to actually write malicious data back into the company's main Salesforce database.
Okay, so that's the problem. It is complex, it's pretty scary, but it is not hopeless. So what can we actually do about it? Let's walk through a blueprint for defense that you could apply to your own applications. Security experts recommend what's called a defense in-depth strategy. Think of it like 3 layers of armor. First, at the web layer, you just use basic security hygiene. Validate what users are typing in. Simple. Second, at the AI layer, you need what's basically a firewall for AI. Something that checks prompts for malicious instructions both on the way in and on the way out. And third, at the data and tools layer, you have to apply something called the principle of least privilege. If an AI only needs to read data, its API key should be read-only. That's it. You don't give it the keys to the entire kingdom.
But there's a final, kind of hard truth here. As our AI systems get more and more complex, especially with what they call agentic systems, where you have multiple AIs all working together, this defense stuff gets exponentially harder. Every layer of security you add can slow the system down. And like the expert says, there's always a trade-off between giving an AI more power and keeping it safe.
And all of this leaves us with one critical question. We are in a technological arms race. The attacks are evolving at a breakneck pace, and they're being driven by a global community of both ethical and, well, not so ethical hackers. So as these AI systems get more and more powerful, more and more embedded in our daily lives, the real question is, are our defenses evolving fast enough to keep up?